If I am giving the wrong password, that should not reflect on my database at a particular time. When there is no consistency in the data, at that time errors will going to be generated. That is what erroneous transaction logic will going to be lead to the inconsistency. Once the system get restarted, at that time it is the responsibility of the log to understand what was the previous stage before the system crash has been takes place. Hello everybody, a warm welcome to one and all. Welcome to the session 1 of Unit 2 of its chapter 1 called Transaction of BCA's 4th semester subject called Database Management System. In short, it is DBMS. I am Rohini TS, Department of Computer Science, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. So in our today's session, we are going to discuss about this chapter 1 of the second unit. So we'll see what are the content that I have in my today's session. So today we will be discussing regarding transaction concepts. What do you mean by transaction? What are the concepts that you have to consider when it comes to the transaction? And also I will be discussing regarding the transaction states. So if I say transaction, what are the states it comprises of? That I will be discussing in my today's session, along with that very important concept, asset properties. So each character has its own name that I am going to discuss in my today's session, along with a concurrent execution. So in order to overcome the disadvantages of this concurrent execution, we have a serializability. So this is what the content or agenda of my today's session. Let me get into the today's session, that is with respect to the transaction. So as we all know that we are going to use the database in order to store the logical related data. So for example, if I say any manipulations or if I say any insert, deletion, updation, everything will going to be considered as transaction. That means we are performing some of the operation, but the transaction should be either completely done or it should not be nothing at all. That means it has to be done completely or else none of the transaction should be initiated. That is what the transaction. So transaction is nothing but it is a collection of operations that form a single logical unit of a work or called transaction. What do you mean by transaction? It is a collection of operations. So that operation can be read or write operation. So when it comes to the transaction, that can be read or write operation. So it will be a collection of all those operations that form a single logical unit. That unit we are considering that as a transaction. So that it will be a collection of operation or a collection of read or write operation. That single unit or a single logical unit will be considered as a transaction here. As I told earlier, the database system must ensure proper execution of a transaction despite of failures. So when we are performing any of the transaction, at the time database must ensure that the transaction needs to be without failure. So that the transaction has to be successfully completed. So either the entire transaction needs to be executed or none of it will needs to be executed. So it has to execute the entire transaction or none of the transaction part should be initiated. It should not stuck in between. That is what we are analyzing from this statement. Okay. So this is the definition of transaction. So when it comes to the transaction concept, as I told, we got to know the definition of transaction and we have a transaction. In the transaction, we have a read or write operation. So if it is a read operation, at the time we are going to read the content of a database into the program. But if it is a write operation from the program, we are writing the content to the database. That is the definition of read or write operation. So that will going to be performed. So that set of operations or a collection of all those operations, I can consider that as what? Transaction. So that transaction is a sequence of read and write operations on the data item that logically functions as one unit of work. So it can be either collection of read or write operation. It will be a combination or a collaboration of all those operations. Then we are going to call that single unit as a transaction here. And also this transaction is an execution of a user program which will going to be seen by the DBMS as a series of lists. So even that list or that collection of actions or collection of execution of program can be either read, that read means we are reading the content of database to the computer program, and also we have a write operation from the program. We are taking some content and I am copying that to the database, that is write operation. So that here it will be considered as a series or a list of actions, so that will be read and write operations. And also if we have a beginning of a transaction, then there must be an end of a transaction. That is what here. So it needs to be in the form of transaction begin and end transaction. So in between the processing will going to be takes place, but either in the transaction I can say this as the transaction only all the parts has been done, other none of the part or none of the thing needs to be initialized in the transaction. Then only we can consider that set of operations or a set of series or a list of read or write operation as a transaction, that you have to remember here. So and this transaction needs to be indivisible, that means it should be executes entire transaction or not at all. So this is what you have to remember. First definition of transaction, at the time it needs to be entirely done or not at all anything with respect to the transaction, and it performs read and write operation. Read in the sense we are taking the content of database into the computer program, and write in the sense we are taking the content from computer program and we are copying that to the database. So if it is a collection of that read and write operation, then that will be considered as what? Transaction. I hope you all understood. We'll see about the transaction states. So now we got to know what is transaction, what are the operation that we are going to perform with respect to the transaction. So this transaction, as I told, it needs to be either completely done or should not be done anything, right? So then what are the stages we have in the transaction? If I wanted to say this is the beginning and this is the end of a transaction, in between what will going to happen, then which state will be considered as what? We'll see now, that is with respect to the transaction state. So any of the part of a transaction, it has to be in one state. Okay, at a time it has to be in one state. So we'll see now, a transaction must be in any one of the following state. That states include active state, partially committed, failed, aborted and committed. So we'll see the first state, that is with respect to the active state. So as I told, we have a beginning of a transaction and end of a transaction. That beginning of a transaction will be considered as what? Initiation of a transaction. That means we are just invoking the transaction. That stage will be considered as active state. So that it is an initial stage of a transaction. The transaction stays in this stage while it is executing. That means we have started doing the transaction. We are initiating either set of either read or write operation. So it is a first stage of a transaction. Next, what we have? It is partially committed. So you just imagine I have a transaction, okay? So I am just going to invoke it. So at that time it will be in the active state, and I have some more transaction here, like I have some more statement needs to be executed or read or write operation needs to take place. When I am at the end line or when I am at the end of a operation of a transaction, that stage will be considered as what? Partially committed. That means I am about to complete my transaction and I have executed my last transaction. Whether it is completed or failed, that needs to be known. So when we are at the last execution or when we are at the stage of a last statements or a last transaction of a particular transaction, at that time that final statement execution will be considered as what? Partially committed. So now the transaction in this state when after the final statement has been executed. But as of now, what you have to understand, I have a set of transaction operation here, like it can be read, write, anything it could be. So when I'm at the final statement, when I have executed a final statement, but I don't know its result, like whether it is completed or if it is failed, but I have executed all my operation. I have executed all my set of operation, then that will be considered as what? Partially committed. So that in that state, when after the execution of final statement, at that time we can call that as a partially committed. So next, what is this? Failed. So this failed state can be occur in any of the situations, so that unsuccessful transaction or when it is come out of that particular transaction will be considered as what? Failed stage. So that the normal execution can no longer proceed. I can't go further for my transaction. For example, you just imagine I have these many set of transaction in one particular transaction. I have these many set of operations. So in between, if I stuck in this transaction stage, at that time, if I say or if I consider this as a failed state, I can't move further. So I just need to walk out from this transaction. That stage will be considered as what? Failed stage. So next what we have here? Aborted. So aborted in the sense the transaction is said to be aborted after the transaction has been rolled back and the database has been restored to its stage prior to the start of the transaction. So there is a difference between failed and aborted. So failed in the sense what? I can't go further in my transaction. So we are not going to have any normal execution. We don't have any normal execution stage over there. So that is failed. When it comes to the aborted, I can go further, but so it will going to roll back to the prior stage before the failure. For example, you just imagine I have these many set of operations. At that time, in this stage, if it get aborted, at that time what he has to do, the database must ensure that the whatever the operation that we have done till now. So I am done with all the 3 previous operation, but that transaction got aborted in the 4th transaction or a 4th set of operation. At the time, database must ensure that it has to roll back. That means it has to undo the operation whatever has been takes place. So again it has to start from the initial stage. For example, you are sending some money from your phone pay or Google Pay, any of the digital payment you are using. Okay, at that time the amount has been deducted from your account and the amount doesn't reach to the recipient. At the time that amount has been stuck somewhere, that stage is called as what? Aborted. So again it has to initialize again, then that will going to reach us to the receiver without any interruption. So then we can say that that stage was an aborted. So that here after the transaction has been rolled back, that means we are just going back. So till now I have done with 4 set of operations. So when it got aborted, at the time it has to roll back to the previous operations and the database has been restored to its state prior to the start of the transaction. Before starting of a transaction, how was the database? How was the stage? Like what are the scenarios we had in a transaction that has to take place? So as I taken the example of phone pay or Google Pay, at that time you just imagine you have 15,000 in your account. So when you are sending some amount, in between it got aborted. That means the transaction has been aborted. So you have sent 5,000 but it didn't reach to the recipient. At that time, so if we are in this aborted stage, at that time that 5,000 should not be deducted from your account. Even though if it is deducted, it has to credit it back to your account in the normal working days. So then we can say that the transaction has been rolled back. So that example you consider, every stage you can relate to either phone pay or Google Pay, then it will be easy for you to understand. Okay, let me clarify this to the last stage here. So this last stage of the transaction is committed. It is just like a successful completion of a transaction. Okay, so after the successful completion of a transaction, so the stages whatever that we have come across, so that needs to be saved to the database for the further decision making. So that when the transaction is said to be in the committed stage, at the time the transaction in this state, once it has been successfully executed and the database transformed into a new consistent state. So what it means? It is just a successful execution from the beginning of a transaction to the end of a transaction. So now just let me clarify each stage with the example of phone pay or a Google Pay or any of the digital payment. Okay, so when it is active stage, at the time you are just going to enter the amount what you wanted to send and you are going to specify your password. That is active state. Okay, so when you pressed all the password, after that you are just going to click on the right mark or a send mark. So at that time I have executed the last statement. That will be considered as what? Partially committed. Okay, so at the time if the server is busy or if something goes wrong with your network, then it will going to be failed. Again, I can't go back, or else I can't do the previous transaction as the normal way. That is failed. Aborted in the sense what? As I take the earlier example, amount has been deducted from your account but it doesn't reach to the receiver. At the time it got stuck in between. So after that, in normal working days, normal 2 to 3 working days, you are going to get your amount back. That is what roll backing. So we are the transaction has been rolled back. It has come to the initial stage how it was before taking the transaction. That is what? Aborted. So committed in the sense what? You have sent some amount from your account to another account. It has been successfully reached to receiver without any interruption. That is what? Committed. So just imagine that example, then it will be easy for you to understand the stages of a transaction. Active, partially committed, failed, abort and committed. This is what the stages. So here you can see the diagrammatic representation of the transaction states. So in this, transaction will going to be begin. When the transaction has been begun, at the time it will be in the active state. Okay, so once it is in the active state, then it can perform either read or write operation. After that, I am going to have a several set of operations like read or write operation. So when I am at the last stage or last operations of a transaction, then it will be partially committed. So if everything went right, at the time the commit will going to be generated. Once it is committed, like whether it is fail or successful, it has to be terminated. So after this, again you just imagine I am starting one more transaction. That is what I am just invoking the active state. So if something goes wrong, at the time in between some transaction has been rolled back at the time. So if it can't be rolled back, then it will going to reach to the failed state. So even when I am in the active state, I am done with the last operation. Though it is not committed, if it get aborted, then it will reach to the failed state. So you just conceptualize, then you understand. Okay, so here again I have a whether it is abort or failed stage, it has to be terminated. Whether it is successful or unsuccessful transaction operation, it has to be terminated. So when it reaches to the abort, at that time there will be a chances of rolling back to the previous condition of a database. So if it got rolled back, at the time I won't come to the fail. Instead of that, I will go to the commit. So this is how this stages of transaction will going to takes place. I hope you all understood. Let me move to the next concept that is very important concept for your examination, that is asset property. So if I say asset property, when it comes to the ACID, so each character has its own property. Each character will going to specify its characteristics. So A in the sense what? Atomicity, and C consistency, I is isolation and D is durability. So that is permanency that we are talking here. So transaction should possess several properties. So if I say transaction, that is a set or a collection of operation that can be read or write. So it has to have some of the properties. That properties will be considered as what? Asset properties. So that will be considered as asset properties. And what are the asset properties we have in a database? That includes atomicity, consistency, isolation, durability. I will just tell you in brief, you just understand here itself. Okay. So if I say atomicity, atomicity in the sense what? It should be indivisible. So either transaction should be completely done or not at all. That is what? Atomicity. And consistency in the sense what? Whether it is failure or a committed. So whatever the stages we have in a transaction, that needs to be consistent. For example, if I deduct 5,000 from my account, it has to reflect. Okay, so otherwise if I deduct some of the 5,000, then if it is showing me deduction of 10,000, then there will be a no consistency in the data. So that error will going to be generated in the particular transaction if there is no consistency. So if there is a inconsistency, at the time error will going to be generated. So in order to minimize the error in the transaction, the data whatever we have in a database should be consistent. And also isolation. For example, you just imagine at a time I am having more than one transaction. At the time, if one transaction, that should not affect the content of another transaction. It should be separate, like it should not depend on one transaction to another transaction. If something goes wrong with this transaction, that should not affect on the another transaction. That is what isolation. And durability in the sense what? Whether it is failure or a successful of transaction, it has to be stored. Okay, it has to be stored. In order to store that, we are going to have this log file that will going to store all the transaction with respect to the read or write operation what has been takes place in the database. That is what regarding asset properties. So we'll see about the atomicity here. So as I told, atomicity in the sense the transaction should not be further divided. It has to be like either completely done or none of the stages of the transaction has to be initialized, so that either all the operation in the transactions are carried out or none of the transaction should be takes place. That is atomicity. The system should ensure that updates of a partially executed transactions are not reflected in the database. As I told, if something goes wrong in between, so at that time the amount should not be deducted from my account. For example, I'm going to give the wrong password. So if I am giving the wrong password, that is what I'm at the last operation of a transaction. So if I'm done with giving a password, then I'm just going to click the right mark. I'm just going to send. So that means what? I'm at the partially committed stage at that time. So if I'm giving the wrong password, that should not reflect on my database at a particular time. Okay, so once I'm giving a right password, then the transaction needs to be initialized. So atomicity in the sense the system should ensure that updates of a partially executed transaction, that means I'm at the last operation of a transaction, so that should not reflected in the database. Though I am giving a wrong password, if the amount has been deducted from my account, then that should not be the fair thing. Okay, so that you have to, when you are working with this atomicity, at the time you have to consider these many things. And also I can say transaction can be incompleted for some of the reason. What it could be? So something goes wrong in between. For what reason? It can be a transaction can be aborted or terminated unsuccessfully by the DBMS. So when I can say none of the transaction has been take over in the transaction, so that could be for the reason of what transaction may be aborted, but I can roll back and I have to come from a first stage of a transaction and it can be terminated. Everything gone wrong, at that time it will going to be terminated, or it is just a unsuccessful transaction which is done by the DBMS. And also system may crash. So in between some hardware or software failures occurs, at that time there will be a chances of having this incomplete transaction. And also transaction may encounter an unexpected situation and decide to abort. For example, even receiver server is busy, or some network issues happen in between sending some amount of a transaction. At that time also there will be a chances of having a incomplete transaction. This is regarding what? Atomicity. So next we have a C, that is consistency. After the successful execution of a transaction, the database should be in a consistent state. So it has to reflect what are the changes has been made after a complete successful of a transaction. So for example, you just imagine I am going to send 5,000 from my account to someone's account. At that time, so if 5,000 is deducted from my account, then that has to be reflected in my account balance. For example, if I have 15,000, if I am sending 5,000, then once I check the balance after the execution of some of the statement, it has to show me 10,000. Instead of that, if it is showing more than that or lesser than the amount, what actual amount that we have, then we can say that the data or a stage which is not in the consistent form. So when there is no consistency in the data, at the time errors will going to be generated. That is what erroneous transaction logic will going to be lead to the inconsistency. So that after a complete successful of a execution, whatever the transaction of a database has been took place, then that needs to be reflected and that has to be in the consistent stage. So that data on all the system reflect the same state. As I told, if I am deducted with 5,000, that has to credit it to my receiver account. So then only I can say that the data is in the consistent stage. Minus 5,000 from my account and minus 5,000 from their account also is not possible, right? It has to be in the reflective form. So when we can expect this consistency? When there is a isolation. Why? Because isolation in the sense, if something goes wrong with one transaction, that should not affect the another transaction. So that execution of a transaction in isolation format, it will going to preserve the consistency of the database, because when there is no dependency from one transaction to another transaction, if something goes wrong with one transaction, will not going to affect the content of another transaction. So this is regarding consistency. So next we'll see about the I, that is isolation. So that I can say the transaction is following this isolation property, that the execution of a transaction should not be influenced by any other transaction executing concurrently. As I told earlier, if I am doing any of the transaction, that should not be influenced or that should not be interfered by any of other transaction in the DBMS. That is what we are going to call that as a isolation. When there is isolation, there will be a consistency. When there is no isolation, then there will be inconsistency. If there is an inconsistency, error in a transaction will be more. So in order to avoid that, it is necessary to follow all the properties which has been given, so that the transactions are isolated or protected from the effects of concurrently scheduling other transaction. So if I am generating or if I am having concurrent execution of more than one transaction at a time, that should not influenced or that should not affected or influenced by any other transaction, then I can say that our transaction is in the isolation property. So next what we have, that is durability. So durability in the sense what? Permanency. So as I told, once the complete successful of a transaction has been takes place, at the time whatever the changes has been made to the database, that should be stored somewhere else in order to take a further decision. So that after a transaction completes successfully, the changes it has made to the database persist even if there are system failures. For example, you just imagine you are sending some amount. So already you have sent, but your mobile battery is low. So at that time, computer or any of the mobile will going to be shut down. But the amount has to be reached to my receiver. That is what we are going to call that as a durability. So that property must be there. If I say any of the database, at the time if something system goes wrong or any crashes has been occurred with software or a hardware, at that time if I can say that as that is following the durability property, at that time once the complete successful transaction happen, then whatever the changes that has been made to the database, that has to be retained, that has to be stored. So then we can even though failures occurs with the system, the transaction has to be completely saved. That is what? Durability. So that DBMS maintains a record called the log. So as we discussed earlier, it has a log file. So whatever the transaction we are making, whether it is with respect to read or write operation, every transaction operation has to be stored in the log. So that of all the writes to the database, it will going to store every content of read and write to this file called log. That will going to maintain a record. So the log is used to ensure the durability. So why we are going to save our data in a file or any of the record? Mainly for my future use, right? So in the same way, we are going to retain some of the messages, images and all. So everything will going to be maintained by this log. So it will going to ensure the durability of a DBMS content. And also, if the system crashes before the changes made by a completed transactions are returned to the disk. So you just need to understand here, if the system crashes before the changes made by the complete transaction. So I'm done with my complete transaction, but the changes is not yet taken place. So at that time, the system got crashed. So that the data needs to be like whatever the changes has been made before the crash, that needs to be returned to the disk. So the log is used to remember and restore these changes when the system restarts. So if system crashes happen, at that time in what stage it is, the data has to be stored in the disk. So Once the system get restarted, at the time it is the responsibility of the log to understand what was the previous stage before the system crash has been takes place. So that is the usage of having this log. So this will going to used in order to ensure the durability, and also we are going to call that as a record. It will going to maintain all the records that will be considered as log file. I hope you all understood regarding ACID, atomicity, consistency, and also we have isolation, then durability. So if any of the database has this properties, then we can say that it will going to be very effective and efficient. We'll see the next topic, that too with respect to concurrent execution. So we are talking about the transaction. So if I am executing more than one transaction at the same time, then we are going to call that as a concurrent execution. So we are going to have this concurrent execution in order to improve the throughput and resource utilization. For example, you just imagine we have file system. So let me tell you an example. You just imagine I have file system, okay, and I have 10 students in my class. At that time, if I say only one student can use a system at a time. So for example, we have file system. If I say only one student can access at that time only system 1 will going to be used, and remaining system will be free. That means we are not using the resource. Instead of that, if I am saying come all the 5 students and occupy the system, that is what concurrent. I am providing the resources parallelly. I am giving the resources at the same time. That is what concurrent execution. So that this will going to improve the throughput as well as the resource utilization. Instead of saying one student at a time, I can simply utilize all the resources whatever we have. So at that time we are going to have a parallel execution. All the students will going to be executed something with the computer system. So that how we are going to find the throughput here? It is just a number of transactions executed for a per unit time. So at a particular time, how many transaction has been occur. So that will going to, if the throughput is high, then the resultant will be high and error will be low. So if you are taking more transaction at a particular time, at that time I can say that the database resultant will be very speed or fast. And also the CPU on disk can operate in parallel. So if we have this concurrent execution, at the time resource will going to be utilized in a efficient manner. So that at that time CPU on disk will going to be operated in a parallel. So whatever the content we have in a disk, that will be copied to the CPU and it will going to process. Again this will send back to the disk for the storage purpose. That means we are taking the operation in a parallel manner. So though when a transaction either read or writes the disk, another transaction can be running in the CPU. So you can see that we have a disk as well as the CPU. We are using both in a parallel manner. So if we are using the disk for a read or write operation, another transaction which can be either read or write operation can utilize the efficiency of this CPU. That means both the CPU and disk needs to be used and that should not be idle. So that is what the thought regarding this concurrency or concurrent execution. So that the CPU and disk utilization also will going to be increases. Main thing is what? It should not get idle. So the resources needs to be utilized by in a efficient manner, either by doing the work of read or write operation. So there are some of the disadvantages with respect to this concurrent execution. So if I allocate 5 students with a 5 system, at that time there will be a chance that these 5 students only will going to occupy the system. They are not about to leave the system for another 5 students. That means there will be a misusage of the resources and there could be a chances of having the dirt read or write operation, and also lost updates, inconsistent data and inconsistent updates. So these are the disadvantages we have with respect to this concurrency execution. In order to resolve it or in order to overcome from these disadvantages, we have a concept called serializability. As the name indicates, serializability in the sense what? At a time only one transaction will going to takes place. So one after another, that is what serializability. So serializability is a given set of interleaved transaction is said to be serializable. So when I can say the transaction is in the serializable if and only if it produces the same result as the serial execution of the same transaction. So here also we are doing it parallelly, but one transaction will going to take place at a time. So in between, just within a certain time, another transaction will going to be takes place, again another. So it will be like one after another. So for the people or a user, one who is seeing this transaction, they won't feel that this transaction is taking place one after another, but it will going to work as a parallel. So that is what serializability. So serializability is a given set of interleaved transaction. Then we can say that that needs to be in the serializable. Serializability is different. Serializable is different. Okay, so that serializability in the sense it is an interleaved transaction. One transaction will going to take place after another transaction. When I can say it is in the serializable, if and only if it produces the same result in the serial execution of the same transaction. So this is what serializability. And if it is serializable, at that time this has to match to the procedure of this serializability. Then I can say that is serializable. Okay, so here main thing what you have to understand, concurrent execution in the sense more than one task will going to take place or more than one transaction will going to take place at a particular time or in a parallel. But in the serializability, one transaction after another transaction. So if it is concurrent execution, at the time transaction will going to be takes place in a parallel manner. But if it is a serializable, at that time one transaction at a time and further transaction will going to be takes place. It's all about today's session. I hope you all understood. In my coming session, we'll go with a second chapter of your Unit 2. So that includes relational data model, relational constraint, relational algebra, relational model concept, and also we have a key constraint, domain constraint, along with a referential integrity constraint. We'll meet you in the next session. Until that, keep learning, keep on growing. Thank you.